All right, let's actually play some games with those formulas we had. I just have cosines up right now because we're going to talk about cosine in this video. We can play the same game with sine using all those different, using that form. Because our cosine goes cosine, cosine, sine, sine. It doesn't keep the same sign, right? We got to get the chant down, or however the heck you remember sine. So we have cosine of 15 degrees. We want to find the exact value of it. Now here's the game. Your homework does a pretty good job of walking you through it. I think a little too much. But we want to be able to come up with two different numbers, subtracted or added together, they equal 15. Why? Why don't I just solve it? Do you know cosine of 15? Do you just have that one on lock? You're like, oh yeah, I can use that table. Maybe not. What this is we want to find two numbers that we know something about them. Like, do we know anything about cosine of 30? Do we know anything about cosine of 45 degrees? Do we know cosine of 60 degrees? Yes. Could we use some sort of combination of 30, 45, and 60? Use two of them to create 15? Come on, dude. 45 minus 30 is equal to 15. What about 60 minus 45? They both equal 15, don't they? So let's rewrite cosine of 15 degrees. Let's write down that it equals cosine of, and which one do you want to use? I'll use 45 minus 30. What the hell? We'll put 45 minus 30 in there. There's alpha. There's beta. Right? Beta, beta, alpha, alpha. So now we can do these things in our head. And here we go. So I'm just going to write it out, how cosine works. Cosine's difference formula goes cosine of the first, cosine of the second. Cosine does not keep the same sign. And then it goes sine of the first, sine of the second. So we'll put in our first 45s, go in the first ones. They go alphabetically, and then we'll put our 30 degrees in the second ones. Now, do not worry about this frickin' sign. It's already taken care of in the problem. Don't be putting in negative 30, then you'd be doing a sum. Careful. Now, what we have is 4 individual problems to solve. But we already know these. I've been begging you to learn all these values, right? You got this. So cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is also root 2 over 2. And sine of 30 is equal to 1/2. You put it all together, you get root 6 up top, because root 2 times root 3 is root 6. 2 times 2 on the bottom is 4. And root 2 times 1 is equal to root 2. And 2 times 2 is still 4. Oh, shoot, look at that common denominator we got. So root 6 plus root 2 all over 4. And that, my friends, is the solution. That's the exact value of cosine of 15 degrees. Exactly. Now, we could have done this in the same way by using 60 and 45. I'm going to run through and use this one now. So we could have said that cosine of 15 degrees is equal to cosine of 60 minus 45. So now we can write it in as cosine 60, cosine 45. Plus, we change the sign and we go sine of 60, sine of 45. Because it goes cosine, cosine, sine, sine. It does not keep the same sign. We go through and we solve cosine of 60 is equal to 1/2. Cosine of 45 is root 2 over 2. Plus sine of 60 is root 3 over 2. Sine of 45 is root 2 over 2. We put this all together, we get root 2 over 4 plus root 6 over 4. Oh shit, that's the same thing, just turned around. So this is root 2 plus root 6. I'm pretty sure addition is commutative, and this is the same dang answer. Huh? 2 different ways, but we got to the same solution. So it doesn't matter as to which one we use. We just use one. Let's move to this. Let's go with let's go with sine of 75 degrees. We'll mess with that one. And then soon I'll start hitting you with the radians, but it's easier to see the stuff with degrees. I would advise, if you have it in radians, just change it to degrees. It makes it much simpler to play this game. Now we want to come up with 2 angles we know something about that will add or subtract up to 75. And I think adding might be better here. Right? Wouldn't you think maybe we could do a little something like this? We could call this is equal to sine of, let's go 45 plus 30. Yeah? Now do you remember sine's chant? Sine of an angle plus another angle, or alpha being 45 or beta being 30. It goes sine, cosine, cosine, sine. It goes alphabetically too. So sine, cosine, cosine, sine. Sine keeps the same sign. Sine, cosine, cosine, sine. It keeps the same sign, and it goes alphabetically. So when we go to plug this one in, we can just go sine of 45, cosine of 30. Keeps the same sign. Now we go cosine of the first one, sine of the second one. And there's our 4 things we need to solve. So we get root 2 over 2. We get root 3 over 2 plus root 2. I swear, have we seen these numbers before? Yes, it's the same freaking game over and over. So that's root 6 over 4 plus root 2 over 4. Are all the answers just root 6 plus root 2 over 4? Are they? Well, you already knew the answer, didn't you? You already knew the answer because you know the complementary angle theorem. Cosine of 15 degrees is equal to sine of 90 degrees minus 15. We already knew that. That's the complementary angle theorem. Saying that it's equal to sine of 75 degrees, that it's equal to sine of 75 degrees, that these two things need to be the same frickin' answer. You know what I mean? So there's your first game. Just with degrees. Degrees is pretty mellow. As soon as you start putting in fractions and shit with the radians, that's where it gets tough. But again, your homework does a pretty good job of explaining it through. So maybe I'll give you another video with that. Maybe I won't. I don't know. I'll see you in the next, though.